Hello.
Yes, sir, we can hear you.
Right. The first today's the last day, and we need to fix a date for the exam. What is the best date? It has to be the same time. We need 1 hour for the exam. When do you want to have it? How about next Saturday? Okay. Next week or week after? Can we? Which one you prefer?
The 17th is better, I think.
Sorry.
17th of February is better, I think.
17th is better. Right. Okay. At 9 o'clock. 9 to 10, 1 hour we need for this. Right, okay.
Excuse me, sir.
Yeah.
Is it a physical on ground exam or online exam?
It's online. I send the paper just before the exam, and at the end of 1 hour, you have to submit the answer. So you will have to join from a computer. And that's how we do it. You get 1 hour, and immediately after 1 hour, you have to submit. So it's you have to type out on the computer and submit as a Word or PDF file. I will send the question paper just few minutes before, maybe 5 minutes before the exam begins. Right. The database practical that we did, we continue with the practical today. The person who did you get any chance to try it out on your computers? How many of you have tried to create a database using the software? I had also given you an assignment to prepare a database schema for the database of your choice, and you don't need a lot of data layers. You don't have to actually create data layers. You just have the names and attribute names, and that's all. And it's a conceptual database. Conceptual in the sense it is a database that it can be populated by digitizing the features, but it is an empty database that you are it's simply a schema. You don't even create your database in your computer. You simply do it using Excel. So that's the model that you can use. It's just the schema of your choice. Your database has to be something that you are familiar with. The data that you are going to use for the database are things, let's say, that you need for some project you are thinking of. So you select the themes that you are interested in, create a few, not create, identify a few data layers, and then document it. That's the schema. I can send you an example, which I will do. So when you submit your, when you have your exam, by the time you have exam, you should have submitted the Excel sheet as well, or you can submit it together with the exam paper. Then you can get the results quickly because I have to submit the marks of this component to Professor Dhammika, and she will upload the marks. So we can finish this segment of the MSc course and move on to other courses. So that's the idea. So we is the person who worked on the database last week present today? I forget her name.
Yes.
How far did you go after working with me on the computer? What have you done so far? Just can you brief the rest of the group what you did?
Sir, I tried it again. Then I can digitize it well before that segment.
How many data layers did you produce?
Only 3 data layers.
They are? What are those data layers?
Restaurants.
Restaurants.
Bars and lounges.
Yeah. Cafes.
Cafes. And
diners.
Diners.
Okay. Now, for all these establishments, customers can review the quality. The customers visit the places, and then they can write a review and publish. Now, if you want that review published in the geodatabase, this is how you can do it. For each establishment, we have four or five establishments: restaurants, bars, cafes, diners, and so on. For each of them, you can write a review. Now, this is how you can do it for individual data layers. Like other data types, the review has to be an attribute in each of the shapefile or feature class. In this case, each of the feature class, you can add an attribute to it in order to enter descriptive information. Now, you have already incorporated a rating system, which is quantitative. You assign quantitative, which is also descriptive. It's verbal categories like poor, good, fair, and so on. So that part we did for few data layers or for all of them. Now that to implement that, so you have to have a field attribute in your attribute table, and we used the domains to list out the values that we can enter into this particular attribute. So 5 attributes, 5 values can be entered to the the ranking or the rating field. So the rate is from poor to excellent. Now this kind of using the verbal or descriptive terms is quite common. And the way the descriptive term, which is what we call the domain, we saw two ways of adding a domain. One is coded domain. So you type a number and the description. Description is verbal category. So in order to enter this kind of field into your attribute table, it has to be a integer field. So that's what we did. I mean, the data is described. We enter data as numbers, but data is described using verbal category. So that was very simple. It behaves almost like any other attribute in the attribute table. So there are a lot of data layers. Each layer can have a field to enter this kind of information. Okay, it doesn't have to be a restaurant. It can be any kind of establishment people utilize. So you give a assessment. Now, only requirement is that the establishment is or establishments are geographically distributed. So that's. But let's suppose that you want to write. You visit this place several times. You want to write several reviews. Let's say you visit the place several times over the time, and there is some improvement that you have observed over the years. So you might want to update and provide, without deleting the old information, you want to enter a new review on a different date. To do this in this format, to do this, you have to create another attribute. That's a problem. The other thing is, let's suppose you are not the only one who would like to enter this information. There are other people also want to enter information into this database. There is no provision for that. Only one entry is possible if you have one attribute. If you have many attributes, then it becomes only way to do it is to have many attributes, but then it becomes unmanageable. It's messy. That's one problem. The other problem is now all these establishments, 4 or 5 establishments we have selected in this case, share the same kind of attributes. They all share the same kind of attributes, although at the moment we have them as different data layers, different feature classes, or different feature classes. Let's forget about shapefiles. Shapefiles are not permitted in the geodatabase. So this is also a little bit messy. Since all these feature types share the same attribute, same attributes, there is no reason to have 5 separate feature classes. We can combine them. A similar situation would be, there are many other examples like this. For example, you have the road layer of a region. Roads are classified into 5 or 6 categories. You have main roads, secondary roads, jeep tracks. If you go by the maps, you have jeep tracks, footpaths. The maps don't have, but in some cases we gather information about trails, particularly in areas which have ecotourism, like Nakas, or in the national parks, like Horton Plains. All these places have trails. You can only take the trail. You can't go away. You can't visit other places without specific permission. The permission that you can get is for research work or something, but usually you have to remain in the trails. Now, all these are some kind of roads, and that means they have same basic characteristics. For example, a road has a length, road has a type, road may have a width, road may have a number of lanes, if it is divided road, number of lanes, like that. There may be the surface condition, whether it is carpeted or gravel road or whatever, that because some jeep tracks also have a solid surface. Some minor roads or secondary roads may not be having a surface. Maybe it is still a gravel road. So this kind of complexities are there. Right now what we do is we can list this kind of categorical data. We can enter categorical data like the name, road, the category of the road can be listed in a single variable, single attribute. But if you want to enter the characteristics of the surface or the width of the road, width is so for each road type you can't have a width, so it has to be entered in a common field. In this kind of situation, we might want to group these roads into the road types, road classes. For road classes, there are specific management tools. Therefore, it is better to have them categorized that way. So all this can be done using subtypes for any given attribute. You can formalize your data entry. To minimize errors, you can have a domain. Domain can be a range domain or a coded domain. So domains can be added. Since the roads are classified into categories, then we can have subtypes for each road category. So the freeways will have, but they are thematically the same. Number of lanes can be common to all of them. So we can group them. When we say number of lanes are common, when it comes to like jeep tracks, footpaths, and things like that, then of course you can say one lane. Okay, they don't have, or 0 lanes. They don't have lanes. They don't have defined lanes. The footpaths and jeep tracks. So 0 to whatever number of lanes. This kind of information, so we can basically enter by grouping the road types. So there are many such data types. River network, for example. Those of you who have done geology or geography would know a river network can be ordered. So from tiny streams to large networks. So the tiniest streams, undivided fingertip streams. These are the segments of the network which is right at the top of the landscape of the river basin. So they can be given order 1, and the order increases from the watershed up to the end point, which may be a lake or the ocean or whatever. So first order streams are undivided, and then second order streams, when 2 streams join, the order increases by 1. When the 2 similar orders join, the order goes up by 1. That is one method. The other method is you simply count the number of fingertip streams and give the order. But the system where whatever method you use, the order of the network increases as you go down from watershed areas to the outlet. So the river, each of these segments, first order streams have river basins, the drainage area. Second order has a bigger drainage area. Third order has bigger drainage area. And the entire network will have the largest draining area. Draining area means when the rain comes, the surface flow ends up in the river channel. So this is taken out of the system from the outlet. That's how the river functions. So there are many situations where this kind of classification, categorization of a theme is possible. For such things, we can use a domain. Okay, we can use a domain. We can, sorry, not a domain, subtype. Now, domain is used to restrict the things that you can enter into an attribute. That way you can maintain data integrity. So this case, if it is a coded domain, of course, you can only select a value from an existing value. You cannot enter a new value. You have to enter what is already there. You might think there is a limitation. Yes, there is a limitation. Limitation in the sense that you identify five categories and you have 5 ordered domains. Okay, so your ordered domain contains 5 categories. Later you find another category that cannot be entered into this database. What can we do then? So do we leave that out, forget about it and proceed? No. You can actually repair your domain. You can add another category to your domain so that the new data can also be entered. So that flexibility is there. Also, if there is a particular category which you originally thought there would be at least once, but you later find that such data is not present in your database, at least. You may have got the schema from some other database, some from outside. So when you realize that it is not there, you can even remove it later on. So you can revise your domain. Now, okay, without complicating this, you have the domain. You can enter categorical data into the domain using the coded domain, or you can enter quantitative values using a range domain. What in the coded domain, you cannot type a value into the relevant place in the attribute table. The cell value has to be selected. You can't type it. That way, errors can be reduced. The errors would be that when you enter some verbal category over and over again, even a simple spelling mistake or capital simple entries can complicate your data layer. So that can introduce unnecessary category. If you write a particular type, a land use type, let's say T, in one location you type T T with capital T. At another location, you type it all simple. In another place, you might type it all capital. Computer will interpret these as not as mistakes, but as three different land use types. Okay, it is not confined to land use. For any categorical data type, this happens. So the software is case sensitive, and that can complicate, introduce unnecessary categories. For example, if you generate the legend, you symbolize the land use types using a legend. In your legend, you will have 3 entries for T. That is the problem. So that can be eliminated. That problem can be eliminated by simply giving a value in a coded domain. Right. In the case of data entry, quantitative data, you can't use coded domains for quantitative data because quantitative data is usually on a continuous scale. So between two values, the minimum and maximum, there are infinite number of possible values that you can enter. So that is to a certain extent simplified by the number of decimal places. So infinite becomes finite when you define the maximum number of decimal places that you can have. Then you get a finite set. Even if you have 10, 20, 30 decimal places, you still get a finite set. But and if you get integer numbers, well, I mean, it's not finite actually. So you basically in all cases you get infinite set because your whole number can increase indefinitely. Same thing with the integer values also. So that means you can inadvertently enter 1 or 2 digits too many when you at the point of data entry. The common example is when you have a lot of numbers with zeros, we might at certain locations we might get we might enter an extra zero to the number. So that's an error. So this problem can be solved to a great extent by limiting the number of digits that you can enter. So we define a range for the attribute. So this particular attribute will have a range. Any value outside the range cannot be entered. So that's the purpose of a range domain. Okay, still you can enter infinite number of values, but still you have that restriction. And of course, the infinite number can be controlled, make it finite by defining the number of digits that you can enter. So that we can decide at the very outset how many places we have for numbers in a particular attribute. If you say 3 places, so whatever number that you can write, you can enter with 3 digits can be entered. So it won't be infinite, it will be finite. So that kind of controls are possible by defining the range. If the range is not there, you have no control over the data entry, because it's not one person entering data. There will be a lot of data entry operators, and some of them can make mistakes. Still within the range you can make mistakes, but there is no solution for that other than checking, getting somebody else to check the data. But entering unusually large numbers can be controlled this way. That's the domain. Okay, that's the purpose of the domain. Second one is the subtype. Now, subtype basically subdivides the feature type. We classify the feature types that we hope to enter, but they all have other attributes the same. Okay, area, maybe land use. For example, we can have 20 subtypes, 20, 30 subtypes, which would be the individual land use types. Still, they all have the polygon, each polygon has an area, which is basically common attribute. The land value or whatever, those things can be entered. So those are common things. Subdividing, grouping is possible. Since we did domain with the exercise we did earlier, today we are going to do work with the subtypes. In our example that we were working on, we had several types of eateries, places where you can drink or dine. You have diners. We don't have to stick with this categories. The diners is specifically American. The other diners would be like our hotels. On the roadside, you have these hotels, tea shops and boutiques where they serve food. And those are cheaper, maybe not cleaner in our setting, but in other countries they are also good, cheap, and they serve quickly and all that. So you have those. Then you have restaurants where you can, restaurants are usually more expensive. So you have, you can have a meal there. And then you have cafes, maybe to eat something and have a tea or something. It's cafe. Then you have bars and lounges. Bars specific serve alcoholic drinks. Lounges may serve coffee or something, but those are places where you can go and sit down. Usually in hotels, you have lounges, places where you can rest, maybe read the paper or whatever. In addition, can have a coffee or something. So this kind of categorization that we put deliberately, we grouped deliberately bars and lounges as one layer. But bars are different from lounges. Still, we have them in one category in our database. How do we work with this kind of data? Now, if you look at the data that attributes that you entered into into these data layers, they are pretty much similar. We have a name, we have a website, we have a rating system, and of course the other things are automatically generated shape, ID, FID. Those are automatically generated. But other than that, a website, rating, name. Those are the common attributes. All of them have these common attributes. So should we have all these things in separate layers, or is there a possibility of joining them together? If we join them together, how do we join them together? Since the attributes are common, we can simply add another attribute to the attribute table of a single data layer. By this attribute, we can identify the type of the establishment. For example, we can have, let's say, an attribute called type. Under that, if it is a restaurant, we type restaurant in there. If it is cafe, we type cafe. So we have that kind of possibilities there. So by using an attribute, we can enter the type. It may be repetitive. There may be quite a bit of redundant data when you do that, because each entry has to be, for each attribute, each establishment, this attribute field has to be filled. So restaurant, there may be hundreds of restaurants, and if you have an attribute to as type, we have to type the restaurant, the word restaurant. We have to enter the word restaurant 100 times. Now, particularly when you are working with land use data, you may have thousands, hundreds of thousands of polygons of different types. So each land use type will be repeated over and over again, hundreds or thousands of times. That means we are increasing the data, the amount of data that we have to keep in our database. in such situation, you might be wondering, do we have to type, if you have 1,000 polygons of T, do we have to type 1,000 times the word T? It is not necessary. You can instead enter a code, let's say 2-digit code that we enter to T polygons. Now, let's suppose that we have altogether 30 different land use types in Sri Lanka. So wherever you do your mapping, there are 30 different land use types maximum. So if you think of a code, for numeric code for each land use type, numeric or actually it doesn't have to be numeric or a string code for these land use types. Numeric, we need 2-digit code, 2-digit code for numeric. For text, you have to have a unique code. Doesn't matter how many characters you are using. So fewer characters, the easier. And after entering these codes, when you finish digitizing your map, all you have to do is select all the polygons with a particular code and type the word T, rubber or whatever once. So what the computer, the software would do is copy what you typed into the appropriate cells and populate all these cells. That means if you have 1,000 polygons with T, the word T will occur in your database 1,000 times. So that's a lot of data that you are entering. So if you want to keep your database lean, that's not a good idea. Why don't we keep the actual name of the land use in a small table? So it only, you have the land use types only, 30 types of land use, and therefore you don't have to physically enter this data into all these places. So that kind of thing is possible when you are developing a database. So you can prevent errors happening, and you can also reduce the volume of data that you want to enter. You can keep your land use types, the long names, in a table. Let's suppose we don't have an attribute field defined in order to enter this data. Without an attribute table, also we can basically use the database connectivity in a project. This is only in a project. So when the project is deleted, that link will also be deleted. So how do we do this? Let's take something like, so the attribute, the feature class has an attribute table. Let me see if I can. Okay, this is the attribute table. So this attribute table has this many cells. Now, the attribute fields I have here, sorry, not attribute fields, the feature classes that I have here, not suitable for this kind of thing, but let me still show you the procedure. Now, in order to link your shapefile to an external table, we can use a certain facility that is available. Now, right click on the, can you all see my screen?
Yes, sir, we can.
Yes.
Okay. I click on food and drinks table. Oh, I click on bars and lounges table. Right click. When I right click, the available options list is displayed. And in this list, there is an option called joins and relates. If you use this join command, you can actually join the attribute table of bars and lounges to an external table. External table you have in your, so this is not confined to a database. You can do it even for shapefiles. You can join to a table. This is what it looks like. Join. You get this. You get in the previous half of this course, you did the conventional database management. Now, in that, you must have learned how to join two tables. Now, the table one is the table of the source table, which is the bars and lounges. Okay. Choose the field in this layer, bars and lounges layer, that the join will be based on. So this is the source. Let's say something unique or something, let's say category. Now category. So I have to have a table which describes, which provide additional information for each of these categories. So second table would be an external table. It can be another shapefile, or because shapefile has a table, or simply a standalone table. Select that table. From here, in this project, I don't have another table. That's why it's like this. You can actually, this second table, you can get from this also. That means it is there in the somewhere else. Okay, I'm getting an external table. Using the word category, I don't have that in this table. So category should have an equivalent field in the external table. So it doesn't have to be called category, but the numbers should match. So that would be 1 to 1 or 1 to many cardinality. And then you can say, okay, so this will basically join a layer to a table, external table. Now this joining is temporary, confined to the project that you are in. ArcMap project you are in, or ArcGIS Pro project you are in. This link, this connection is valid. If you delete the project, that link will disappear. Okay, so that's not a permanent link. Whereas the database links are permanent. As long as you keep the database, it's permanent unless you revise. Okay, that's the difference. Now, so we have 4 categories, 4 or 5 categories of establishments. Each category can be considered as a subtype. That will allow us to separate bars and lounges as well, because bars are different from lounges, and therefore we can separate them as well. So we have to redesign our database. Redesign in the sense this particular 5 feature classes can be combined into one feature class. So that is what we are going to do today. Now, let me stop sharing. Let's get the person who worked with us last week, and we can proceed from where she stopped. Can you start your ArcMap and share the screen? Let me enable you.
I didn't save it, sir.
You didn't save it?
Yeah.
Okay, it's okay. But do you have the data in the computer? Project you didn't save, but you have the data.
Yes.
Okay. Let's start your ArcMap. Share screen. Okay, screen is shared now.
Now my computer is going slow. It's not opening the ArcMap.
Not opening ArcMap.
I opened it. It is very slow, sir. Not opening.
You can open our catalog also. While we are waiting for the ArcMap to start, do we are we happy with the domains? Are there any questions? You don't have to wait till others, those who understand how the domain is defined, that would be good enough. Someone has indicated he or she cannot hear. Is it the case still? I think we need to communicate verbally rather than chat is not that efficient when you can speak. Is there anybody? Okay, first, how many of you understand completely how the domain is defined? Okay, I go by the names. Nadi Kuruvitage.
Yes, sir.
Can you speak actually instead of me reading out your names individually? Just think that you are the only person in the class and answer the questions I ask. That way we can get some responses from you. Otherwise, each one of you would be waiting for the other person to ask a question or say something, and nobody speaks. So this is very difficult for me when we are doing this online thing. Even in a classroom, it is the case, but it is far more difficult when you don't open your mouth. The question I asked was, are you comfortable with the definition of domains?
I think that the domain is what we can understand about the attributes, but I can't understand properly about the purpose of the domain.
Purpose of the domain is actually to group the objects.
What about the links? The relationships and the links are the same to.
Relationship is a different thing. Relationship. You have a domain, you have subtype, you have relationships. We didn't come to relationships yet. We define the domain. By defining domain, you make your data entry faster. And also you avoid entering, you avoid typing, having to type the same thing over and over again. You simply pick the attribute value from a list. That is the advantage of a domain. So you avoid the whole concept of domain. The reason why we have a domain is fundamentally to maintain data integrity, prevent you entering values outside the range or having to type values over and over again, same thing over and over again. Because when you do that, you can make mistakes. You can make spelling mistakes. I told you that the software is case sensitive, and therefore, if you give a different combination of uppercase, lowercase values, the letters, then you are going to change the attribute type. Is that clear?
Yes, sir.
Yeah, T can be spelled as using capital letters, first letter capital, all simple. So 3 common ways of doing it. All 3 are accurate grammatically. But from the point of view of the software, those are 3 different names because this software is case sensitive. That if you are using a ordered domain, coded domain, you can prevent that happening. Okay, but when you are entering quantitative numbers, we can define, we can set upper limit and a lower limit. So all our entries have to fall within that range. That means if you happen to hit the 0 key once too many, then you might one too many. You might change the value. So if there is, if you want to, let's say your maximum number is 1000, you can't type 1001 or 10,000, for example. So when you are entering data, 1, 3 zeros. Sometimes you might enter 1 and 4 zeros. That kind of mistakes can be avoided. Right, okay. You have diners, cafes, restaurants, bars and lounges. So bars and lounges are 2 different types of establishment. In this database, we have considered them as one feature class. Okay. Now we want to first we want to group them into 2 categories. Same feature class, but we have 2 feature types. So here the domain is not what we want to use. Okay, we want to use subtype. Subtype bars are identified separately from lounges. So bars and lounges separate. So subtype 1, subtype 2 can be used for this purpose. Now, this work can be done using there are 2 ways of doing this. You can either use catalog in ArcMap. There is a catalog. Catalog is when you click on catalog, it's the browser. It is very similar to Microsoft browser. Okay. The other method is actually the catalog is available here as a separate independent program, which is called ARC Catalog. And it is run independent of ARC Map or any other ARC product. So you can run it as ARC Catalog or Catalog. So ARC Catalog and Catalog do pretty much similar things. Therefore, we are using Catalog here. Now, Catalog button is immediately below in your ribbon bar. The top one is the menu bar. Okay, menu bar. And the second one, no, we don't want that. Second one is the button bar. It's one of the buttons that you have. When you click on that, something happens. Okay, next to the red button is actually the toolbox. You have this 119,447. After that, go to the right until you meet yellow box like thing. Right, that is the catalog. Click on the catalog. Okay, you can expand it a little bit. Okay, now this is the catalog. You can expand it here. We are working with the catalog here. Okay, now go to the place where you have your database. In the catalog tree, go to the folder where you have your database. Okay, go inside. Now you have restaurants. Right, okay. You have bars and lounges. Right click on bars and lounges. Properties. Okay, properties. The properties dialog box will appear, and in that you have all these categories. You have subtypes. Click on subtypes. Okay, now we are going to create a subtype field. Click on the down arrow under subtype field. Okay, its rating is there. Okay. Wait. You have to in the bars and lounges. You have to start by adding another attribute. You cancel this, bars and lounges. Okay, right click again. Go down, properties. Okay, go to fields. Okay, these are you have 4 attributes: object ID, shape, name, rating. Now, in the below rating, you can enter a new field. Right there, the field name is category. Type it in capital letters. Category, capital. I said category not because of anything, just to make it more visible from the other layer. Okay, type would be short integer. Okay, apply. Okay, subtypes. Now, you could have selected subtypes from there. It's okay. You just right click and properties. Okay, subtypes. Yeah, click. Now select category. Okay. Now below this box you have it has created a new subtype and code is 0. Just one subtype. What you can do is keep 0, replace new subtype by bars. Then another one, type 1, and 1 is lounge. Okay, apply. Okay. Like what you did earlier, you have to assign the subtypes to the feature class. Okay. What feature class is this? Okay. Now go to edit. Okay. Open the table. Start edit. Right. Okay. Open the attribute table. Rating is there. Right. Category. And click on null. Right. Okay. Now, since you define the subtype, any given point in this data layer, okay, any given point that you have digitized, any given object in your data layer would be either a bar or a lounge. Earlier, there was no such a thing. You can digitize few points using your Google image. Those points can be arbitrary. Some of them are bars, some of them are lounges. You need to digitize. There is only one point, I think, in the close the table. You can get the attribute table. Can you place the cursor? Right. Go and go back to your editor. There is the arrowhead. Click on that. Arrowhead. Next. Right. Go to the map area. Right click. Right click. Can you click on arrowhead again? Okay. In the map area, right click. No, you didn't right click. Select attributes, sorry. Attributes. Okay, resize the attribute window. You display only one record, and therefore you don't need a large box. Reduce the height. Okay, maybe width you can increase a little bit, but height is too much. Now, can you, right, there is this vertical line on the right hand side. There are two buttons, right hand button. Yeah, click on that. Click on the button. All right, okay, okay. Now, digitize a point or select a point which is already there. The point can be arbitrary using digitize tool in bars and lounges. Okay. Now, before rating, it doesn't matter how you do it. Click on category. No, down arrow. In category, down arrow. Okay. Let's change it to lounge. Yes, say yes. That's a warning. The computer is thinking you might be making an error. Give a rating, again a value between whatever the value you can select. Okay, that's okay. Now go back to the map and digitize another point. Now wait a second. Now in this particular case, there are two types of establishment: bars and lounge. Let's say 75% of the time you get bars. This particular area has more alcoholics, let's say. So there are more bars than lounges. So the new point you digitize, you have higher probability that it is a bar, not a lounge. In such cases, we can declare that this particular object is by default a bar. So whenever you digitize a point, in the attribute table, it appears like a bar. I think in your one, this has happened already, maybe not on purpose, but accidentally it has happened. So when you are defining your subtypes, you must have enabled the automatic or default value. You might have enabled the default value as bar. Right, click another point to check this. Checking means that when you create a new point, it will automatically appear as a bar. So it happened. So you digitize a point and it came out as a bar. So if you have more bars than lounges, this is a good method so that the data entry happens automatically. You don't have to do anything. Only when you digitize a lounge, you will have to change bars to lounges. Okay. Alternatively, let's say even when you have 50-50, if you know the point that you are digitizing is either a bar or a lounge, so you have 100 points to digitize. If the majority are bars, you can keep on digitizing, and only few times you have to make the value. Few times you have to change the value. 75% of the time, if it is 100, 75% of the time, the value automatically entered is correct. But 25% of the time, your intervention may be required. Is that clear?
Yes, sir.
Okay. Now, the other method is using the same method, but the other way of digitizing is you digitize all the bars first, then lounges later. Then the lounges will have to be changed. That's all. So that is also possible, but this is the way how this works. Now, the next exercise is that since all these, if you look at all these data layers, let's see what the attributes are in each of these data layers. Can you open the attribute table of diners? Okay, it has, you haven't entered the, you haven't entered the you haven't entered the names. Okay, let's say you have N. N can be A, B, C. Go to the next one. So that has correctly name, rating, category. Close that. Restaurants. Okay, this also doesn't have the correct attributes. What you can do is enter okay, you don't have to enter into these things, but it looks like all these things have common attributes. Now, shape and object ID are common to all of them. They are automatically generated. Then we have the name, ranking, the rating, and then we can add a new variable called category. So what happens if restaurants, diners, cafes, bars and lounges, all these data layers, now we have 1, 2, 3, 4. We have 4 data layers. All 4 data layers can be combined. Okay, the whole 4 data layers can be combined. And use subtypes to identify them separately within the data layer. So subtypes can be used there exactly in the same way that we use subtypes with the bars and lounges data layer. Okay, so I want you to create a combined layer which is called, we have a name for it. Forget the name that I have. We can create a name. So we have to define a subtype field. Okay, create another new data layer. The data layer, let's say, let's come up with a new name. Let's call it drinks and food and drinks. Feature class. Food underscore, you can't have spaces. And okay, food, drinks. Underneath alias, type, food, and You don't need underscore and drinks. So the first name is the actual name in the database. Second name is what appears to you. So the first one has to meet the format requirements. The second one, basically anything, some user-friendly name. Okay, food and drinks. Okay. Feature type is point, not polygon. Right. Okay. Yeah. Now here you have to enter some attributes. Attribute first name. Now name text. Click on text. Check on the length of the name. Now here we have 50 characters. Length is 50. We don't need maybe 30. Okay, the next variable, rating. Rating is short integer. Okay, rating. Next one is description. Text. Text, yeah. And next one is review. We are interested in people reviewing this review. It is text. Now, if you are writing a review, how many words will you have? And your field that you define must have adequate space. Now let's stick with 50 characters. With 50 characters, very little we can write, but let's stick with that at the moment. Say finish. Okay, now we have to define the domain for certain attributes, subtypes for certain attributes. You have to go to the ARC catalog in order to do this. Subtypes, okay. Let's define the subtypes first. We use the, wait a minute, we might need, is there anything for subtype? We need another attribute for category. So go to the fields, type category. Use capital this time. Category, No, category short integer. Right, say apply. Subtypes. Okay. Subtype. Select category. Subtype field. A subtype field category is not recognized for some reason. Define domain here. No. Okay, subtype field. Is the fields. Short integer. Okay. Short integer. Click on domain. No, you have to assign. You have to assign the domain. You go back from our catalog. Property. No, domain has to be from the database. Domain has to be defined in the database. Okay, rate in domain that we are using rating. Okay. Click on rating. Okay, a short integer. Domain type. We want coded. It's okay. You have 1, 2, 3, 4, 5. Right. Okay. Say okay. Again, right click, database, property. No, you have to click, define subtype. Can you remember how we did it last time? Subtypes. Subtypes are created within the feature class. Okay, now category is there, right? Is it the food and drinks data layer?
Yes, sir.
Then you create the subtypes. No, the type of the establishment, restaurant, whatever. Yeah. Those four types: restaurants, bars, lounges, cafes. Okay, apply. Right, okay. Now go to the digitize something for the new data layer. Food and drinks data layer, edit enable. Okay, now you have to have this attribute no, not that. This shows entire table. So we want only just one record. Arrowhead. Click on the arrowhead tool. Yeah, that's the tool that is used for attributes. Right click, attributes. Now place the attributes under the digitizing box underneath that. Can you reduce the size of the digitizing toolbox? Reduce the height, so push it up. Place the attribute thing below, and you don't need this left and right boxes of the same size. Resize the text box, the attribute box. You see only one record at a time. Rating field has not been assigned, is it? Not been defined. That's category is okay working. What about the rating? Rating one is not assigned properly. So you have to go back and assign the rating. You have to go back. You have to stop edit. Right click on the database. No, you have to use the category. Yes, sorry, catalog. Catalog. I think you are not using the right thing. Domain. Category, okay. Domains, no. Authenticator, okay. Did you click on the database? Right, remove this. Right click on the database, which is restaurants, property. No. Click on the food and drinks. Food and drinks. We put areas as food and drinks, but it's not properties. Domain. There is a place where you assign the domain to the relevant field. Keep on forgetting these things. Okay, click on the rating field. Rating field, okay. Description, domain properties, coded value domain is there. Okay, that part is okay. The domain is defined, right? You need to assign the domain to the data layer. Click on category. Click on domain, empty box. Nothing happens, right? Rating, click on rating, sorry. Rating. And then domain. Right, okay, rating. Select rating system. Right, apply. Okay. Now it should work. Arrange the two boxes, one above the other. Attribute, keep it in one place. Digitize tools in one place. Maybe it's a good idea to keep them in the same place, because then your brain knows where to focus. So quickly you can access the attribute dialog box and the toolbox. Right. Now you digitize and you have selected already the point. So rating, click on rating. It's not properly assigned. Category is okay. Domain is not assigned. Something must have happened when you're trying to do it last time. Go back and do it. Others can also help her. I am wondering why it appears as food underscore drinks. Go to the name field. Attribute field names, okay. The food and drinks feature class. That was when you created the feature class. I think you gave the alias. If you give alias, then that is the name that should appear. Anyway, I don't know if there is another. You see, there is the food and drinks layer. I don't know if you are working with that. Okay. Go to the domain. No, no, not here. So click, remove this text box. Go out of the edit session. Go back to defining a domain, assigning domain. No, you always work with the catalog. Remember, now, when you are doing digitizing and things like that, data entry, always using the editor. Anything else you do would be with the catalog. Okay. Now you are assigning rating to the domain. Rating, click. Okay. What is the domain name? No, that's where the problem is. You have to create a domain name in the database. In the database, you have to create the domain name, then you can assign the domain. Okay, let's not use the same name. Customer rating or something, you call it customer rating. Okay, domain type coded. Click the attribute table, open the attribute table. You don't have, you haven't digitized anything. There is no data. Digitize the point. Digitize few points. Okay, click on rating. No, nothing comes. This is how you do it. Right click from our catalog. Right click the feature class, properties. In the fields tab, select rating field, and from field properties section, select rating system domain property. Field properties, we need the rating is there. Is domain name correct? Your domain is rates, but it's rating in the top box.
So it's working on the attribute table.
Huh?
It's working on the attribute table, the
Is it
rating.
working in the attribute table?
Yes.
Yeah, it is working, right. Okay. Then try in the attribute table, attribute record on the right hand side. I tell you what, can you make it bigger, that box bigger? Wider? Not that box, the right hand side. Can you extend a little bit? Okay, click on, still not. Okay, try the attribute table and enter the data. Something somewhere must have gone wrong. Arbitrarily assign values. Okay, now we do another thing. Okay. Right, remove all those things. Okay, we are going to create a review table. It's called object table. Now, object table has to be created inside the geodatabase. So you go to geodatabase with our catalog. Our catalog. Right, okay, catalog. Expand it. In the name, restaurants, right click. New. This is common whenever you want to create a new layer, feature class, feature dataset, table. Table also can be created here. I don't think. Now your database name is new geodatabase. The name of the database is new geodatabase. New. Okay. Now see table. Okay, the name of the table is diner underscore review. Underscore review. So in the name field, you can't have spaces, but in the alias, you can use the common readable name. Diners reviews. Okay, top one also you can diner reviews. You can have more than one. Diner reviews. Okay, here object ID is the default thing. Next line review text. Review text. Now by default it has click on the text. Okay, 50 is not enough, so we have to give it 3,000 or 1,000 or something. That means 3,000 characters can be typed in that field. Any number, large number, yeah, would do. Right, then finish. Sorry, go back to that table. Few more things have to be added. Not domains. Table. Diner reviews, table. Properties. Okay, table properties, fields. Okay, type, review date, review underscore date. It's a date field, date field. Diner underscore object ID. This is the object ID of the restaurant or whatever it is. Through the object ID, that's all. Through the object ID, you can assign the reviews to each restaurant or whatever. Apply. Okay. So now you have created the database, table, right? Okay, now we have to create something else. This is called relationship class. We have time only to create a relationship class. In order to do that, again from our catalog, right click on the database, new, relationship class. Now, what this means is that the feature layer, that feature class that we created, as well as other feature classes, we can establish the cardinality and the relationship. So this is called a relationship class. This relationship class establishes the link between the independent table and a feature class. That is what it does. Name of the relationship class. The name, I'm going to give a name to you, but it is okay. You can type any name you like. Maybe better, otherwise you will be doing what I say. So type a name for the relationship class. What is this table? Reviews, right? It is not about, it's not food, it is about the establishment. So you are basically reviewing whether this particular establishment is providing the service that you expect for the money. So that is the idea. So these are basically reviews. In this name also you can't have spaces. And underscore, last one would be relationship class. Just say rel or something, or underscore at the end, the top one. Yeah, underscore rel class or something. Underscore rel, meaning relationship class. Right. Diners reviews, okay. Diners. Okay, that's okay. That's the origin feature class. What is the origin feature class? Origin feature class is diner, right? Can you click on this plus sign? Click on diners. Or did we combine all of them into one?
Yes, sir.
Use that name. Diner reviews. Diner reviews are the default. Use the default one. Not there, the bottom box. Yeah, that's correct. Click next. Okay, now simple peer-to-peer. What is the difference between the two? From your database thing, does it indicate any difference between simple peer-to-peer and composite relationship? In this kind of teaching, actually, it's very important that you respond. Otherwise, I will be talking to myself. You should indicate if you know this, if you heard about this, or you are just listening and then forgetting. It is what looks to me. I don't know why others are not participating. It's very only two of us are actually working on this. Others are just I don't know if they are around even. Anyway, for the person who is doing this, at least simple simple peer-to-peer is that when you delete, so you have two tables. One is the attribute table of a feature class. The second one is the external table, which has nothing to do with the feature class. When you establish relationship between two tables, feature class table and the independent table, one becomes the origin table or source table. The other, let's say origin, other is the destination table. So in this case, origin table is the feature class table. Destination table is the external table that we created. So the relationship between the two, that's what we establish. The implications are if it is a mere peer-to-peer relationship, if you delete a record feature in your feature class, that will not affect the independent table. Independent table will still keep all the records intact. If you use a composite relationship, then what happens is when you delete a record from your feature class table, the linked record from the destination table will also go with it. We don't want that to happen. There are advantages in certain cases, but in this, we will not have any benefit by keeping that relationship. So it is not a composite relationship we establish. It is a peer-to-peer relationship. If the relationship is broken due to the deletion of the record from the feature class, it will not disappear from the data table. It doesn't matter. The rest of the relationships will remain active. Right, okay, so we simple peer-to-peer is selected. Okay, now what is the cardinality? What kind of relationship are we talking about here? So the allowed relationships, there are four options. Four options given here. Default option is none, no message propagated. There is no message propagation between the two. So that's not what we want. We want the one-to-m relationship, one-to-many. One-to-many is given forward, origin, destination, backward, forward. Wait a minute, let me check this. We keep the backward destination. backward, destination to origin. Yeah, we keep that. That will, that is the kind of relationship that we form. So 1 to 1 from the origin table, many from the, that is because any particular establishment may have multiple reviews. Okay, multiple reviews from the same person or different people. So that's the relationship we want. Next. Now here, you have options 1 to 1, 1 to m, many to many to many to many. So select the middle one. One to n. Right. Go back. I didn't see what where you were. 1 to m is okay. Click next. Then it asks, yes, I would like to add attribute to this. Add attribute to this. Let's say, no, I do not want to add attributes. If it didn't work, remember this position. You have to come back and redo this. Okay. Next. Okay. Object ID. Select the primary key. Click on down arrow. Okay. Object ID. Name can be used, but name is too long, and therefore object ID, it might be easier. Right, is object ID. Destination. They are also object ID, okay, right. Right, it looks like, okay, this is the summary reviews of customer. Reviews of customer class, again. Food drinks, destination, object class, diner review, type simple, forward path, level, diner reviews, backward, food and message propagation, backward, destination to origin. Cardinality 1 to n, right? Attributes, origin, primary key, object ID in both forward. If this didn't work, you can create different ID later on. Try this out. Okay, finish. The idea is that you can enter your comments, one record per row, and you can type many rows, but make sure that the establishment ID is assigned correctly here. So you have to get the assignment ID from there to this one, from the feature class layer to this one, and that way you can, if it didn't work, what you can do is you can create ID, object ID field, different from the default one. So that's where we stop here. You need to practice this over and over again because the steps are too many, and therefore remembering them is very difficult until you basically memorize all this by doing it over and over again. Best thing is to prepare a document. The document that I provided was prepared quickly, therefore it has a lot of other stuff also. But what you can do is, for each of these things that you learn, prepare stepwise procedure document while you are at it, and then this will remain with you for the rest of the course as well as later on. So do that, and that will most important thing here is to learn about these various facilities available in general when you are working with geodatabases or other spatial databases. I don't want you to stuck with the geodatabase, because still it is a proprietary one. It's a commercial product. There are other public domain software, geodata, spatial databases, not geodatabases. Geodatabase is proprietary. Like the other available, I mean, there are other commercial spatial databases as well, or conventional databases like Oracle, for example, now has a geo data facility, and like that. Eventually, all these things will be combined into one. So that is the future. But remember, if you have S3 licenses, then it is okay. But otherwise, I think open source is the most affordable for us. Affordable in the sense there is no cost involved except the hardware requirements and so on. With that, we finish this class, and then the exam would be in 2 weeks, 1 hour exam, and you have to prepare the Excel sheet to show some conceptual GIS database. Don't need data, so it is not a geodatabase. It is not a physical geodatabase. It is simply the schema which will contain important information for you to develop geodatabase. That is the metadata that you require to prepare geodatabase. Now, you see how complex it is when you try to do it without a document. It's very difficult. So you might kind of miss certain things, and it's better that you carefully prepare a document which list all the components of the database that you want to create. So I will mail model schema. You will have to create a schema, not for the exercise that we did. Don't use that. Produce a geodatabase, something relating to your own area, maybe work related, something, or it's an offshoot of your work related things. People usually do things which is other than the job. So something interesting you might encounter while you are doing your work to produce a kind of a limited scope geodatabase, thinking that somebody might need that kind of thing. So there is no data going into it. There is no software involved except Excel. So that's the conceptual model, the schema of the geodatabase. So with that, I finish this class, and I will immediately send the document. Okay.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah. Okay.
Thank you, sir. Thank you, sir.
Bye.
Thank you very much.